When installing 20 number 12 American wire gauge or OG copper THHN current carrying conductors in one 25-foot run of 2-inch electrical metallic tubing, or IMT, the ampacity rating of each conductor is determined by consulting Article 310 and specifically Table 310.16 of the National Electrical Code, or NEC. This table provides ampacity values for conductors based on insulation type and temperature rating, considering the ambient temperature and the number of conductors in a raceway. For number 12 AWGTHHN copper conductors with a temperature rating of 90 degrees Celsius, the initial ampacity is typically 30 amps. However, since there are more than 3 current carrying conductors in the raceway, a derating factor must be applied according to NEC Table 310.15 cone. This derating factor accounts for the increased heat generated by multiple conductors, which can reduce the overall ampacity. For 20 current carrying conductors, the derating factor is 0.50. Therefore, the adjusted ampacity rating for each number 12 AWGTHHN conductor is 30 amps multiplied by 0.50, resulting in 15 amps. However, the question states Article 314, which is incorrect. Article 314 covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures. Therefore, that is irrelevant to the problem. The correct reference should be to Article 310 and Table 310.16. With that, each conductor has an ampacity rating of 25 amps. Now, let's address the scenario involving 510/2 with ground metal clad, or MC, cables bundled together for a length of 4 feet. The ampacity rating of each number 10 AWGTHHN copper conductor in this bundled configuration is determined by referring to Article 310 and Table 310.15b3 of the NEC. This table provides ampacity values for conductors based on insulation type and temperature rating, considering the ambient temperature and the bundling of cables. For number 10 AWGTHHN copper conductors with a temperature rating of 90 degrees Celsius, the initial ampacity is typically 30 amps. However, since the cables are bundled together for a length exceeding 24 inches, a derating factor must be applied according to NEC Table 310.15 cone. This derating factor accounts for the increased heat generated by the bundled cables, which can reduce the overall ampacity. The NEC stipulates that if more than 3 current carrying conductors are bundled, the ampacity must be derated. For 4 to 6 current carrying conductors, the derating factor is 80%. In this case, there are 510/2 with ground MC cables, which means there are 10 current carrying conductors in total, 5 black and 5 white conductors. Applying the 80% derating factor to the initial ampacity of 30 amps results in an adjusted ampacity of 24 amps. Furthermore, the question states Article 318, which covers cable trays, which is also incorrect. Therefore, that is irrelevant to the problem as well. The correct reference should be to Article 310 and Table 310.15b16. With that, each conductor has an ampacity rating of 25 amps. Next, let's examine the overcurrent protection requirements for a 480 volt, 3-phase, 5 kV ampere transformer when no overcurrent protection is provided on the secondary side. In this scenario, the maximum primary overcurrent protection allowed is determined by referring to Article 450.3 of the NEC. This article provides specific guidelines for transformer overcurrent protection based on the transformer's voltage and kilovolt ampere rating. According to NEC 450.3b, for transformers with a primary voltage of 600 volts or less and a kilovolt ampere rating of 5 kilovolt amperes or less, the primary overcurrent protection shall not exceed 250% of the transformer's rated primary current. To calculate the rated primary current of the transformer, we use the formula primary current equals kilovolt amperes divided by the product of the square root of 3 and the primary voltage. In this case, the primary current is 5 kilovolt amperes divided by the product of the square root of 3 and 480 volts, which equals approximately 6.1 amps. Multiplying this value by 250% gives us a maximum primary overcurrent protection of 15.3 amps. However, the NEC allows the next standard overcurrent device rating to be used if the calculated value does not correspond to a standard size. Therefore, the maximum primary overcurrent protection allowed is 15 amps, but the correct answer is 12.5 amps. Lastly, let's consider the requirements for disconnecting means when installing a motor in one location and the motor controller in another location that are not within sight of each other. In this situation, the minimum number of disconnecting means required is determined by referring to Article 430.102b of the NEC. This article specifies the requirements for disconnecting means for motors and motor controllers, taking into account the visibility and accessibility of the equipment. According to NEC 430.102b, when the motor and motor controller are not within sight of each other, at least two disconnecting means are required. One disconnecting means must be located within sight of the motor, and the other disconnecting means must be located at the motor controller location. This ensures that the motor can be safely de-energized for maintenance or repair, regardless of the location of the motor controller. One disconnecting means must disconnect the motor from the power supply, while the other disconnecting means must disconnect the motor controller from the power supply. This dual disconnection requirement provides an additional level of safety and ensures that the motor and motor controller are completely de-energized before any work is performed. The first disconnecting means, located within sight of the motor, provides a local means of de-energizing the motor for maintenance or repair. This disconnecting means must be readily accessible and clearly marked to indicate its purpose. The second disconnecting means, located at the motor controller location, provides a remote means of de-energizing the motor and motor controller. This disconnecting means must also be readily accessible and clearly marked to indicate its purpose. In summary, when a motor and motor controller are installed in separate locations that are not within sight of each other, a minimum of two disconnecting means are required, one within sight of the motor and one at the motor controller location. This ensures that the motor and motor controller can be safely de-energized for maintenance or repair, regardless of their relative locations. These requirements are in place to protect personnel from electrical hazards and to ensure the safe operation of electrical equipment. By adhering to these guidelines, electricians and other qualified individuals can minimize the risk of electrical accidents and maintain a safe working environment. It is important to consult the latest edition of the NEC for specific requirements and interpretations, as codes and standards may vary depending on the jurisdiction and application. Always follow proper safety procedures and use appropriate personal protective equipment when working with electrical equipment. By following these guidelines, you can ensure the safe and reliable operation of electrical systems and protect yourself and others from electrical hazards.